Okay, hello everyone to our 6th programming class. This is going to be just a bit of a review, which is why I see nothing in the chat right now. But yeah, it's just going to be a little bit of review, and we're going to go over what we did last time. And, we're going to make a new little shooter subsystem, and hopefully it stays in your memory this time. So I was asking, what do you guys remember from last time? And we have a nothing. That's an answer, right? So you can remember nothing. Anyone who remembers slightly more than nothing? Constants.java, and you can put constants in it. Okay, did you watch the video? Actually, you don't even have to watch the video from last time. You know what? You can learn, because it's just a review of like the whole commands thing. So do you know Java? Did you watch those videos? Do you have like basic understanding? Yeah, a bit. Okay, that's good. Whatever. If you don't fully understand, this year is coming to a close. But next year we will be partying because it's going to be cool, and COVID is hopefully going to be gone. So I really do implore that you suggest your friends to join robotics, that you join robotics, and you will be given sort of more jobs and more roles since you do have the experience. We're hoping that it's not a disaster like it was last year, right? It's been a year. Yes. Rip indeed. Can you believe SpongeBob ripped his pants? Was it pants or jeans? Either one of those. He ripped one of them. Okay, so it is 3:05. That's enough preliminary talk. Let's get right into it. No, Armand, I was just referencing. Okay, don't worry about it, Armand. Okay, so I'm going to share my window. Okay, so I upped the font size this time. Hopefully it looks better, because I remember last time it was really hard to read. Also, I'm recording on the robotics laptop itself this time, so hopefully that works better as well. Can you guys read it and see it? Like, is it actually legible this time? I thought it was. I don't know, though. No, but answer my question. Is it legible? But not the video. Ah, okay. Oh, well, yeah, that would make sense, because I recorded my laptop in the Google Meets meeting. That was intelligent, yes. So much of brain cell usage. It's okay, I'm recording on the laptop this time, so it's going to be better. Anyways, yeah, so we're going to make our shooter, right? So let me just give you sort of an auditory description of what the shooter was like last year. Well, the way that we had it set up was basically, it was like, imagine a stick of a cannon, so it's like flat, right? It's a flat cannon, and so balls come in from one end, and they get shot out from the other. But we wanted to keep it on an angle, right? Because you want to shoot your things in sort of an arc. So we left it on an angle, and we put a piston on the bottom, a pneumatic piston. So we used air pressure to move up and down. And this piston would allow it to, move up and down. So there's a state where it was up and it was facing upwards, and there's a state when it was down and it was facing like sort of at a 30-degree-ish angle. In theory, yeah. Well, regardless, the code for it did work, so we don't have to worry about that. It's just a little bit of a complication. So let's get right into making our subsystem. So remember, a subsystem is basically going to be a collection of parts in a robot, so a collection of electronic parts on a robot that we group together into one system because they have one function, or they do one general thing, right? So if I have a motor and which is connected to sort of like a lift system, then that's the only part of my lift subsystem, because that's only going to be used for lifting. If I have 4 motors for my drive system, that's the only thing that's going to be used in my drive system. And sort of going off of that logic, that's how we sort of divide the robot into different parts. And when we divide it into different parts, it makes it easier to manage, right? So if there's an error, the error is occurring in the drive subsystem. That means that one of these parts is not working, or one of these parts is not programmed correctly. So it makes life easier for us. It makes life easier for the robot code. And it's just a great way to sort of organize everything. And commands, essentially, what they'll do is they'll use one or a variety of these subsystems to perform an action. So if I have something that's like drive and shoot or something, hit and run, drive and shoot, then what I'm going to do is I'm going to need the drive subsystem, and I'm going to need the shooting subsystem, the shooter subsystem, right? So it's going to use 2 of them. And if we have like drive, shoot, and Batman, then it's going to like drive, shoot, and then it's going to grappling hook somewhere. Then we need a grappling hook subsystem, right? So that's just sort of how we organize our code, and that's how commands work. So commands are interlaced with using different subsystems to perform some action. And that's just how we divide our code, and that's the basic logic behind it. So if we're making a shooter subsystem, do you guys know how I shouldn't say guys, do people know how shooters would work in, or how a what a shooter needs to shoot the ball? Like, what does it use to shoot the ball? For those of you who've taken mechanical classes, this should be a fairly easy answer, what the most popular option is. For those of you who haven't, it's okay, I'll sort of explain it. What electronic parts are used to shoot the ball? Like, what normally does the robot use to shoot a ball? Motors, yeah. And how are the motors arranged? What do the motors do so that a ball is shot out of the cannon or from whatever system? Yeah, there are many, but like, yeah, for a thing last year, I think Flywheel is the most common though, right? Am I not? Yeah, okay, yeah, Flywheels are, yeah, I was asking for the most common. Okay, so, gun. Sadly, we cannot use guns because I don't know if we're allowed to use micro explosives or micro detonations, because I really did want to use those, but I don't think we're allowed to. I also did propose a trebuchet idea that didn't really plan out, so it was unfortunate. Regardless, a flywheel. So how does a flywheel work? Basically, it's going to be a motor that has a wheel attached to it, right? And so what it does is when the ball touches this motor, the traction of the wheel will sort of attach, not attach, but the ball will sort of get caught into the wheel's motion, and then it will fling out. So either there's a surface on the other side that compresses the ball, or there are two wheels that compress the ball, but the ball needs to be compressed, and it moves upwards through this series of motors, and eventually it gets to the end, and it's freed from this compression at some high speed, and it's shot out. That's how it should work in theory. Obviously, there are different ways of doing it, and I explained it very poorly. If you care more about that, I suggest checking out the mechanical recordings. But yeah, we do, so you need, we had a double flywheel last year, which means we had two motors spinning together, which would shoot out the ball. What stops it? The motors, they move in one direction, right? Like the wheels don't move omnidirectionally, they move in one direction. So,
what do you mean, how do you shoot the ball the other way? What does that even mean?
I don't know.
Just turn the motor the other way.
Yeah, self-implode the robot, but like, no, it just won't move forward then, because there's no force. The force comes from the pressure of going through the entire tube, right? So there's a tube, and it gets more and more pressured, and then it's eventually released. And along with that release, there's a high speed, which allows it to fling out. Shooting mechanics aside, because this is not a mechanical sort of lesson, we had a double flywheel last year, which meant that we had two motors spinning in tandem together, which would allow for the ball to go through that. And at the end, these two motors would spin really fast, and they would shoot the ball out. Of course, there's a chain that went out to the back as well. So we're going to be making sort of our shooter, but except for just the shooting part, there was also one other thing I mentioned, the two states. Do you remember what I was talking about? There's something that allowed the shooter to move up and down. What was I saying? There's a special word I'm looking for. It starts with a P, but it sounds like it starts with an N. Yes, pneumatics, hoorah. So pneumatics are like, using air pressure to get blow boys. Yeah, using air pressure to get stuff done. And so to control these pneumatics, we have devices called solenoids. And so solenoids, put very simply, it's basically air goes in through one end. There is a little motor on the inside which blocks the gate. You send electrical signal, the motor moves the gate, and now the air goes through. And then you move the motor back, and it closes, and now there's no more air going through. So it's very simply either the gate is open or it's closed. And that allows you to send different levels of pressure outwards. Not different levels, but it just allows you to set the pressure up or down. And the pressure goes into a piston, which lifts something up. If you care more about the electronics of it, I suggest checking out the electrical lessons, because I did a whole thing on pneumatics. But we're going to be using something called a solenoid, and that's what we use to control the airflow. I'm going to sort of explain the logic behind it. Armand, if you have a video of how it worked last year, that'd be really helpful. If you don't, that's perfectly fine. I'll try to explain it as we go through making the code. But we know what we need now. For shooters, yeah, like how it lifted up and down.
Well, at the end we fixed it, but I'll find a video. Okay.
Yeah, okay. If you can find a video, that'd be nice. But yeah, I'll try to explain it as we go along in the code. Regardless, let's get right into it. So I'm going to we know what we need. We need 2 motors and we need a solenoid device, right? And so, give me 1 second. There you go. And so now we're going to make our thing for this thing. We're going to make our subsystem for this. And so we're going to call this shooter.java. I suggest getting that open. It's going to be an empty Java file so far with this stuff. We're just going to go to our example subsystem and copy this because this is the exact sort of boilerplate code or the format code we want. And since we're changing it, we're going to need to change the name of our class as well because we're changing the name of the file. So it's going to be shooter. And we need to change the name of the formula as well, or the constructor. Okay. Does this seem familiar to you all? Are you familiar with what I just did? Does this make sense? Because this is all about it making sense to you. I want to make sure that we understand what exactly I'm talking about, and we're good to go for when I continue for the last programming lesson. So does this make sense so far? I should probably tab this properly. Oh, wrong thing. I changed the class name, and if you notice over here, this is the constructor. So the constructor used to be, no, this will unformat my things. It used to be example subsystem, but again, that's not the name of our class anymore, so we need to change that. Right? Cool. Creates a new shooter. I need a better name for this. Maybe shooter. Maybe shooting subsystem is a better one. Whatever, shooter. Shoot. Would shoot work better? No. This is a very appropriate FRCT, okay? Your code needs to reflect the value and morals of Chingokusi Secondary School. Okay, so are we good so far in terms of this? I said Chingokusi. There's a kusi in there. Like the Italian accent, but a very bad Italian accent. Or maybe like this is my first time in Brampton, what are you talking about sort of accent. Okay, I'm going to assume that we're okay. It's really hard to get sort of user input when all I get is like, I'm going to be very frank about this. Unfortunate jokes. So whatever, I'm going to assume that we're good with this. Okay, if you remember from last time, when we made our drive.java, we'll look over how we made our motors. So first we need to initialize empty motors over here, or empty classes. So there's no value attached to them, we're just signifying that they exist. Do you guys remember why we keep them on the outside and not inside this thing? Why are periodic and symperiodic different? Because, hold up, I should close these. Save. Do I need to save here? Did I change anything here? Don't think I did. Okay, not close. If it breaks apart, that's my fault. Tank drive, I think this is generally the same. Tank drive.java, yeah, I don't think I changed this. Example subsystem, not relevant right now. Settings, not relevant. Okay, workspace is clean. Periodic and symperiodic. So simulation periodic is going to be when we use our simulator. So our simulator uses a different cycle because it simulates physics values. And as such, we have different things to do. So we're going to plug in those simulated physics values into our robot to calculate how much energy it would use and so on and so forth. And so because we have this advanced mathematics stuff, we use simulation periodic because there are different things we need to do if it's in a simulation, and if it's an actual periodic, we need to do physical things, right? So less. And so to make that differentiation, we have periodic and simulation periodic. Simulation periodic only runs if the current situation is a simulation and not actually deployed code in real life. Okay, so I think that was answered. Let's go back to the question I had over here. So why do we keep this on the outside? Why don't we keep it inside of this constructor over here? Do you guys remember? I'm going to take your silence as a no. So the reason why we keep this on the outside is because we want it to be known to the entire class, so to all of the rest of the code in the class, that this exists and it needs to be used throughout the class. If we only put it inside of this constructor, it will only exist inside of this constructor. It won't exist outside of this constructor. But if we put it here, it exists everywhere inside of these curly brackets. And so in Java, a very simple way you can sort of check where what exists is basically going to be sort of which bracket is it the closest to. So since this is closest to the top, everything inside of this, or next to this, I guess, within this top level bracket, is going to involve these variables over here. And so we want to make sure that the motors are involved everywhere else inside of our class. And so as such, we're going to add that in. So we need our WPI Talon FX, and that's going to be the class for our motor controller. Again, we installed the dependency for this last time. So if you're a bit confused on how to do that, or your computer isn't to there yet, I'm going to do that very quickly. So on Classroom, you'll see a post with a link on it, and it says that this is a dependency. It's going to be a .json link. Okay, you want to copy that link, do Command-Shift-P or Control-Shift-P. You're going to go to WPILib, or type out WPILib, and they're going to go to Manage Vendor Libraries. Once you click Manage Vendor Libraries, you're going to do Install New Libraries Online. And then you're going to enter in the link that you got from the classroom. And you should be good to go then. It's going to do some fancy stuff, but after it says Build Complete, you should be good to go. I'm going to hide this because it's not very relevant right now. So since we have two shooting motors, we're going to call one of them shooter left and shooter right. Now, they're not shooting balls to the left or balls to the right. They're just sort of the positions of them, right? So there'll be one to the left and one to the right. If we put them on top of each other, there'd be one on the top and one on the bottom. So we could either call them shooter 1, shooter 2, or shooter left or shooter right. Which naming scheme do you guys prefer? 1, 2, or left, right? Left, right. For the love of God. Okay. Thank you, Armand. You want left, right. Okay, so we're going to make a shooter left variable, and this is going to be the motor for our left shooter. We're going to make a shooter right. So obviously we're spoiled here, and we have a Falcon 500 that can be used for our shooters. Not the case in our actual robot, but these are essentially interchangeable, so I wouldn't worry much about it. Also, they have built-in encoders, so I don't know why I did the encoder thing last time, but that was an important lesson, so hey. Anyways, we have the shooter left and shooter right. What else do we need? We need the pressure controller, which I call the solenoid. So, solenoids, there's a single solenoid, which only controls one airflow, and there's a double solenoid, which controls 2 airflows. So we're going to be working with a double solenoid. I think it's, yeah, double solenoid. And we're going to call this our lift system. Or, yeah, lift. Lift, double solenoid. There we go. And so that's going to be the lift, or the double solenoid that's used to lift the shooter. And that's essentially, I think, most of our code in terms of the initialization. Yes, I think we're good to go. Okay, perfect. So now we're going to head over to our constants because we need to get the electrical pins for these. Remember, they all have a pin. So we're going to go to here, and we're going to make them for our shooter. So we're going to say public static int, and we're going to call this shooter left number. And the number is the CAN number, which corresponds to whatever thing. So if you're on the electrical team, that matters to you. If you're on the programming, you just need to plug in the number the electrical people tell you to. So we're going to say that this is 7, and we're going to need a public static int shooter right number, and this is going to be 8. There we go. Great. Now we're also going to need the pins for our double solenoid. So we're going to do public static int lift double solenoid pin 1, and we're going to say that this is equal to 4. These are really long names. Public static int lift double solenoid pin 2, and we're going to say this is equal to 5. Just in correspondence with the previous pins we've assigned here and the previous numbers we have over here. Perfect, so our constants have been updated. We're going to add that into our shooter. So now we're going to give a value to these. So when we make a new shooter, these exist throughout the shooter, but now we're going to actually get the electrical value of them, or we're going to make of an instance of it in the code. So we're going to say shooter left equals new. We're going to say WPI Talon FX, which is the thing that we need, and we're going to go constants dot lift double solenoid pin 1. And you'll notice that it imported automatically up here. If you press tab, it'll do that. If you're getting red squiggly lines and it says something is not imported, you can just fix it quite easily using the quick fix option over here. Constants.lift double solenoid. Oh wait, no, why am I using double solenoid pins? I'm going to go shooter left number, and we're going to go shooter right number. Okay, hello. You missed a decent amount, but we're just doing review from last time. So right now I'm just going to make a shooter subsystem for our sort of shooter from last year. Okay, great. So we've made our left and right shooter flywheel motors, right? That's cool. That's good. Swell. Now that we've made those, we need to initialize our double solenoid. So we'll say lift double solenoid equals new double solenoid. And when you're initializing a double solenoid, I think you'll need 2 integers, which are going to be your 2 pin numbers. Did they leave? The recording will be posted on YouTube, so if you're late, don't leave, please. Okay, great. So now we've gotten those motors on. That's perfect. And if you remember from our drive, you remember that we set a brake mode over here, or set a neutral mode. So here we set it to brake, where it will stop, or it won't move. In a shooter, what mode do you think would be optimal for a robot, for a shooter system for the motors? Should we keep them in neutral mode, brake mode, so that the balls don't move at all? What should we be doing? I'm asking you because I honestly have no idea. I mean, I think the brake mode is appropriate because we don't want the balls to fall out of there. So yeah,
if you're shooting multiple balls, then it's probably not the best.
What, brake mode?
I can never mind it because your power is not going to be at 0, so it doesn't really make a difference.
Yeah, I don't know.
It doesn't really matter. It doesn't matter.
Doesn't matter. You know what? It doesn't matter. It's so unimportant. It doesn't matter. So we're just gonna we're just not gonna do it. You know what? That's a good way of thinking about it. Thank you, Armand. Okay. Don't worry. It was not a very relevant question. Okay, so now we've constructed all of our variables. We've given them all a value. Does everything make sense so far? I think this is the part where most people were confused. Or this is the part where I would be very confused. So I think I'm going to impose that upon you. Are you guys confused right now? Say yes in chat if you are confused. Great. Thank you for your honesty. Do we have 1 yes, 2 yes, 2 yes, 3 yes? All good so far? 2 yeses? Does all good so far count as a yes? Going once, going twice, sold to me. Okay, so what part are you guys exactly, what are you doing in public shooter? I just realized it's a horrible way to name a class. Okay, so in the, when you set the variables, what are you setting? Okay, great. So if you remember the basics of Java lessons, this is going to be a while back, you'd remember that when I initialize something like this and don't give it a value, no. When I make a class like this, it's basically like making a blueprint. It's making a plan for the class, but it's not making the class itself. It's just saying, when this class exists, it'll be exactly like the code I have over here. So when I'm making these, all I'm saying is, these exist, but they don't have any value. They're equal to nothing. They exist only as a name. They exist only as a place, like a placeholder in your computer, right? So yeah, we're making instances. We're making an instance of these 2 motors, and when we're making an instance, we have to specify what CAN number it uses, right? So we have to specify, oh, where do I find this electrically? And if I know where I find this electrically, then great, I will send a signal to it, and once I get a confirmation, I have initialized my left and right motors. And then it's the same for over here. I have the 2 pins. Once I send a confirmation, I have initialized my double solenoid. So I'm essentially, these are placeholders, and here I'm giving them an actual value on the robot. So place on the robot where they belong. And so when I send signals to these programming classes, they're going to actually electrically send a signal to the robot as well, through the robot as well. Does that make sense? Yes. Okay, cool. So then a question, fine. A question then becomes, why don't you just initialize them over here? Good question. And the reason why we don't do that is because you can have duplicates of these classes, actually, and in different ways, too. I can actually have a I can have a shooter constructor that takes in variables, and maybe these variables are like speed or something, right? Speed or something. And when I have the speed, then I can specify the speed somewhere else in the system. So the reason why we do it in the constructor is so that we can have efficient reusability of the code. Technically, because our code is so simple, we can keep it on the outside, but we're putting it in here just for good practices. Okay, I hope that answers all questions, and I hope we're good to go. If you're good to go, put what's in the class. Like you make an instance. I make an instance, But what code is actually in the class? In the shooter class? I need better names. in the class, like the shooter class. So in terms of what's inside of the shooter class, you have these placeholders, but they actually exist, right? So you can still do something with them. It's just they're placeholders. So it's like, imagine it sort of as someone like a how do I explain this? What's a good analogy for this? Like a bench warmer on your team. They exist, right? Like they're technically on the team list, but they don't do anything. You can tell them to do something, but they'll most probably not do it well, or in the sense of this code, they just won't do anything. So they exist only in terms of the list. They don't exist to perform or do anything. Does that help? Yeah, I'm just setting it up. They don't shoot yet. They will shoot, though. Nothing against bench warmers. I mean, I'm a bench warmer for life, my friend. But yes, that's just what it is. Okay, so okay, great. Now I'm going to teach you guys how to use the solenoid. And so, in terms of using the solenoid, it's a little bit complicated, just because of how it sort of works. But I think we can get to it. So when we're using the solenoid, we're only going to primarily be using it to lift and to drop the shooter, right? So it's going to be lift the shooter up and let the shooter go down. And so the way that we can essentially do that is we're going to make a function, and we're going to call this lift shooter, right? And it's going to be void because we don't really need to return anything. We're just going to lift the shooter. Everything makes sense so far. We don't need to return any values. We're just public shooter, basically like a function that can be called. It's a constructor, so it's sort of like when, I'm making it. It's what initializes the class itself, right? So when I say new wapai talon fx, that's the constructor that's making a new object of this type. So I can do new shooter, and it will run the code inside of here. Yeah, okay. So now I'm going to make the lift shooter function, and it's going to just lift our shooter up. So what we're going to do is we're going to set our lift double solenoid, right? And so this is going to be positioned right under the shooter. And we're going to, I think, set. Yeah, it is set. Okay. And we're going to set it to value.k forward. And so what value.k forward means is it's going to basically go up, and it's going to constantly stay up. So when I'm setting it, I'm constantly making it stay up. So the air pressure will constantly be open and going to keep it up, right? So you can imagine it like sort of, if I turn off the air pressure, it's going to fall down instantly. But if I keep the air pressure on, it's going to essentially, it's going to keep it elevated. But then I can slowly turn down the air pressure to drop it down. So when you're lifting it, you don't really have to do anything slowly. You can just set it to K forward. Forward means it lifts up, right? So does that make sense to you guys? Everything I did here, so public void lift shooter, and we're going to set our solenoid to go up or forward. So we're going to set our pistons to go forward. And you'll notice I do import double solenoid.value over here. I did that automatically through the tab. You guys are following on your own computers. Everything makes sense so far, though? It didn't? You could just type it on the top then. If you literally just copy paste it, the line right above is import double solenoid. If you copy paste on the bottom, you just add a dot value. It's the same thing. Okay, so I hope that makes sense. I'm going to continue. Now we're going to drop our shooter, or put our shooter down. And so we're going to make another function, and we're going to call this drop shooter. And what we're going to do is we're going to say lift double solenoid dot set, and we're going to basically value dot k off. And when we set the value to off, we're essentially just going to turn the pressure off. So it's going to quite literally drop our shooter. And so while this works, it's going to be very painful. And painful in the sense that it's going to actually drop your shooter. So if it's at a very high height, it could displace all the gears and everything on the inside, and it could cause damage. And so to make sure that it doesn't cause damage because of how heavy the shooter could be, we're going to actually make things a little bit different. We're going to make a lift double solenoid. We're going to do two things. Dot set. And we're going to set our value to value.k reverse. And so we're going to reverse it, right? So it's going to reverse the flow, which will slowly bring it down, right? And so one thing you could ask is, why don't we just constantly set it to reverse? Because that's basically going to waste our air pressure. And so to make sure that we're not wasting too much air pressure, we can just turn it off to make sure that the air pressure is contained within the loop. Then we're going to set our timer. Which timer am I using here? Timer. This one. Timer. So import this. If you press tab, it's going to import edu.wpi.first.wpilibj.timer. And we're going to basically just delay for a number of seconds. We're going to delay for about 0.25 seconds. And that's going to allow us to sort of reverse it down slowly and then fully turn it off. So make sure it gets down properly and then fully turn it off, because it only takes about that much time. Maybe it takes like 1.25. I actually don't remember. Maybe we have to set that as a constant. We'll do that. That's smart. Good job, me. So we're going to make a public. So go back to your constants file. Static double. We're going to call this time until shooter drops. And we're going to say this is 1.25 seconds or something. Whatever time it is. And we're going to delay for constants dot time until shooter drops. Okay, does this make sense so far to everyone here? Can you go back to constants? Yeah, sure. Yes, you do import that. Can you go back to shooter? Yeah, sure. There we are. Give me a second. I'm just going to run through what I did last year, because I think I did the things without a command. I think I just did it as a thing to do it quickly, which, I mean, good on me, but also pretty dumb for me. What is time unit drop value? Time unit drop value? time until drop value. Oh, I just set it as 1.25. It could just says time until shooter drops cannot be resolved to a variable. Did you write it in your constants file? Is it public static? And a double? Yes. I don't know. Yeah, you might have to say the constants file. I think VS Code does that though. Like I remember it typically does do that. But yeah, just save it. Should work. Ah, unfortunate. Okay, we're good to go, I think. So we've lifted our shooter, we can lift our shooter, and we can drop our shooter. Great news. Now we're going to actually shoot stuff out. So by shooting stuff out, I mean we're going to have to set our flywheel speed. So we're going to make a void, and we're going to call this set flywheel. So remember, we want these two wheels to move together, because they'll have to work together and apply pressure at the same speed to make the ball shoot out and at the same direction. And so to sort of get that set up, what we're going to do is we're going to make a set flywheel function, which will take a speed and move the two wheels at the same time, right? So if I have one wheel on the left and that wheel is spinning counterclockwise, then I want the wheel on the right to be spinning clockwise, right? So they're going to have to spin in opposite directions to move in the same motion. Does that make sense to you guys? Like, can you imagine it if you just have like, put your hands out and then move the left one counterclockwise, and then what direction would the right one have to move to match its motion? It would have to move, like this. So like, yeah. So because of that, one of the directions is going to have to be reversed. And we're going to set that as our left one. So we're going to say shooter left, and we're going to say dot set, right? So set is going to set the speed, right? That's what our double thing is. And typically you do set speed like this and you're good to go. And then you go shooter right dot set speed and you're done, right? But then these would move in the same direction. That's not what you want. You want one of them to be opposing. And since we considered the left one to be spinning counterclockwise and the right one to be spinning clockwise, that would make the general force outwards, right? Like it wouldn't force it inwards, it would force it outwards. And so that would mean we need negative speed in the shooter left. So just set that as negative speed. Make sure you do that, relatively important. After you do that, you're basically done. We're just going to add one more sort of thing, and that's going to be our safety. So we're going to make one last function. We're going to call this our stop. And so this is just for safety, and we're going to say our lift double solenoid dot set value dot k off. So we wanted to turn off. And we're going to say that our shooter left dot set, oh no, it's shooter left dot stop motor, and we're going to do shooter right dot stop motor. Okay, perfect. So now we've finished our class. Please reverse the motor instead. Armand, you make me do so much work. What Armand's trying to do is, I think it's like this. If I recall the syntax, reverse. Config, close the loop, config factory default, get motor, get parameter, get integrated, motion cruise, motion trajectory, neutral deadband, peak, output, remote, reverse limit source, reverse soft limit threshold, sensor term, set parameter, velocity, voltage measurement, integral zone, KD, KF, KP, filter, feed, follow. Follow is basically going to be like it copies the motion of the second one, which we could use here. I forgot how to reverse it. Hold up. Get. No, it's not a get thing.
Can you actually not reverse a motor in Pilot? What?
You can. This is just like hold up. What's this called? Set. Oh, here we are. It's set What is this? Reverse something. Well, no, it's not set. It's okay. Here we go from the bottom here. Set subsystem. I forget where it is. I remember. Set inverted. Yeah, set inverted. This one would be true. There we go. So you do set inverted over here. Life easy. So now you invert the left motor, so you don't have to do this. You just keep them both at speed. In fact, you can actually just do it as shooter left dot follow, and we can make it follow shooter right. If you do that, then you're basically fine if you just do this. But that is fancy code. I don't like fancy code, so we're just going to keep it as set inverted. I do like fancy code. I would implore that you write fancy code, but I just don't want to get too complicated on you guys, especially because you're just learning. Okay, so we've made our shooter subsystem, and we're good to go. Okay, now that we're good to go, do you guys want to learn the command way or the not so command way? The way I would like you to use a command, but you don't use a command for something this dumb, which is why. You know what? I'll just I'll show you guys both ways. I'll show you guys both ways very quickly. So we're going to make a command, and we're going to call it lift drop shooter and shoot ball. Okay, so we're going to make actually instead of making that, I'm going to show you guys the easy way of doing it, just so you don't have to. If you head over to your robotcontainer.java file over here, you're going to want to import your shooter subsystem. So private final shooter. And then you're going to make a shooter equals new shooter. Once you do that, you just do quick fix and you import. It should import it for you. So I showed you guys how to do that over there. So we're going to make a new shooter subsystem. And we're going to keep this with the other subsystem, so actually just Control X. Why is the tabbing on all of them just completely messed up? Okay, great. So we've made our shooter subsystem. Now what we want to do is in configure button binding, we want to lift the shooter if we press the right bumper. We want to drop it if we press the left bumper. That seems like intuitive controls. In actual season, I would want you to use it this way for useless commands like this. I don't waste command space because that's just completely useless. So we're going to go button K bumper left. And what we're going to do is dot when pressed. Actually, no, I think it's toggle. Yeah, toggle when pressed. What we're going to do is when pressed, we're going to toggle something. What we're going to toggle is, and we're going to make an anonymous function here, which looks really weird. I'll admit that. What you're going to do is you're going to shooter.lift shooter. Do you need the... Yes, you do need the second one. Do you? I don't think you do, actually. I'm remembering Java syntax very quick. Yeah, you don't. And so I think that's good. Though there might need to be a return type. Cannot return a void, yeah. Returns this button so the call can be changed. Yeah, so it's gonna be a pain. You know what? We're making commands then. Hoorah. That's fine, whatever, I don't mind. So we're going to head over to the command thing. You typically make them another way, but that's going to be an effort to teach you all. And I don't want to teach you all Lambda commands either. So we're going to make one. We're going to call this the liftshooter.java command. This is going to be the most basic piece of code you have written in your entire life, but I must show you how to write it, so I hope you forgive me. Oh my god, I copied the thing again. Control-C. Control-V. So, since we're not using example command anymore, we're going to change the name to our lift shooter function. And we're going to, which thing do we need? We need the shooter. And then we're going to need the shooter. And then we're going to need the then we're going to need this. Okay, now let me explain what I just did over here. Oh wait, we're gonna need to change the name. Okay, so here, what I did is I changed the name so that it would fit the name of the new file. Great, perfect, excellent. Next, I made my shooter because the shooter is the subsystem I need for this command to run. I don't need two subsystems, I just need one. That's going to be lifting my shooter. Then I changed the name of my constructor because it's going to need to be changed as I made a new Java file and it has a new name. Next, I changed the parameters because we need a shooter to be entered in as the parameter. And this shooter that's entered in as a parameter will then be changed to this shooter over here. And the reason why we do that is basically we don't want to make multiple shooters. We don't want to make clones of a subsystem. We just want one subsystem if it's going to do something. And so we make that subsystem in our robot container, right? So we made our shooter over here. And we're going to use it in our lift shooter command over here. So we're going to set this as a parameter. And then we add it as a requirement. So when it's initially scheduled, we just want our thing to be on. So we're going to do shooter dot lift shooter. While executing, we don't really need to do anything. And once the command has been ended, do we want to drop it once it's been ended? No, we just want to keep it like lifted, right? Yeah, good. So yeah, that's all we need. We just need to lift the shooter on initialize. It's the most dumb thing ever. Why does this exist? Why did I make this? Okay, maybe we do this in execute so that it looks like it does something more than nothing. Next, we're going to import our thing in over here. So we're going to get it private final lift command lift equals new lift and you're going to import this. Did I make the lift command class? Lift shooter, not lift command, lift shooter. It should be called lift shooter command, but whatever. Next, we're going to go to our button. So on our bumper left, toggle when pressed. So when we press it, it's going to toggle. And we're going to say lift command. The constructor is undefined. Oh yeah, we need a dot value over here. And you want to do the same thing for dropping the shooter. So I'm pretty sure you guys can do that by yourselves. Do you understand what I'm saying, by the way? Just so I didn't lose any of you. Do you understand what happened in terms of the command and everything? Would you like me to review? I can do that very quickly for like the last 7-ish minutes. Type yes in chat if you are confused. What if you want to call a command not connected to a button? Like just where would you call it though? Like in Auton? Auton itself is a command. Let's say I read a button, okay. You don't need an if statement. Why do you need an if statement? No, but that counters this entire sort of system. It's called a joystick button for a reason. Yeah, okay, a joystick. So, okay, Arman, I get what you mean, but like the way the system works is, let's say that if you press the button A 2 times very rapidly, you want something special to happen. Then you make a special command for that called like A processing command. And then in there, it'll do all the calculations for that. You don't do the calculations here. This is just to assign stuff to buttons. But the buttons are the only way you'll really interact with these commands. Does that make sense? "15 seconds until teleop. We want to turn some lights on. Then what? Just like 15 seconds into teleop. Then you'd use a command scheduler. So you'd head over to, where's my boy? I think it's in robot.java. Yeah, so you just do command.schedule and you add it to the command scheduler. So you say after auton is done, then you can add a timer with a delay or something, and you can do that. I think you can schedule with a delay, maybe. Yes, you can schedule commands manually if you need to. It's not as dumb as you thought it was. It's actually like a proper programming style. I don't know what you've been using. No, it's relatively proper. I'm pretty sure it's like relatively industry standard too. Anyways, ignoring Armand and his antics, are there any questions we have about commands or anything? Did this at least clear something up for you? I hope it did, because it was like a review thing. Type yes in chat if this was helpful in any way. Okay, great. I got one yes. Yes. Can you go back to the private final stuff in container? Yeah, sure. So, are you confused about... I'll make your homework assignment, add the drop and the shoot commands. So, I'm sure you know how to do that. Private final over here. The reason why we make it... do you want to know why it's private final? Ah, yes, only partially confused. Oh. I will be posting this, and I will also be posting your homework assignment, so... Yeah, you can copy it, though. I hope the better font size did help. But yeah, I think that's the end of it. If you have any questions, feel free to ask them. Other than that, I hope you enjoyed this. I hope it was beneficial to you. And things are beginning to make sense. That's good, that's good. It makes a lot more sense when you actually have a robot and you see it like breaking down. It's all coming together. Yes, yes it is. Soon we will have robot domination. World domination with robots. AKA robot domination. Thank you. Many thanks. 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 Why is the letter A in the English alphabet so weird? It's like alphabet, but then you also have like car. You also have like, what else? Cat. Like cat, mat. All is different too. English is overrated. Okay, well, if there's nothing to talk about, I will be ending this recording. For all of you watching on YouTube, I will post the resources there as well. I've forgotten to put the drive, so I'll update the description of the old video. Beyond that, have fun. Any questions, you can ask them. So, I'll